going to do a very quick explainer here to just show a demonstration for how the Gini index is used to split your classification trees. And just to clarify, this is not something that's required to know. It came up in office hours. Someone asked me about this in a message on Gitter, and so I thought I'd make a quick video for everyone in case anybody else was interested in learning more, but this is not going to be something that you're assessed on. It's just if you are interested in learning more. So if that's not you, you're welcome to stop watching this video, but if you are interested, listen on. So what I'm going to do is I am going to just load the Tidy Models package, and then I'm going to create a quick data set that I'm just going to use as an example. And so just to show you what this data set is, I've got a Y variable here that has two groups, A and B, so that's what I'm classifying. I'm building my decision tree to classify into either group A or group B. And then I have two predictors, X1 and X2. Both of these are binary, they're just ones and zeros. And so what I'm doing is I'm basically building a decision tree by hand so I can figure out which class I'd like to put, or which split I'd like to do first. So in this case, because I have just two variables, I'm going to be calculating just two Gini indices, one for each variable, and I'm going to pick the one that's optimal to make that first split. So usually I would have, if I had more variables, I would have more Gini indices that I'd be choosing between. And if my variables had more than just two levels, I would have additional Gini indices. So for example, if X2, instead of just having 0 and 1, had 3 potential levels, then I would look at splitting at each of those levels instead of just looking at the one split between the two levels. But because this is a simple case, I'm just going to be looking at two different Gini coefficients. Okay. So the first thing, let's try X1 first. So I'm going to take this data and I'm going to create a variable called node. And so what I'm basically doing is I'm trying out what would happen if I created a node that split when X1 is 1, it split the node to the left. And when X1 is 0, I split my node to the right. So let's see what happens then. So I'm going to group by node and Y, and I'm going to calculate the proportion that fall into each of these groups. All right, so down here I've got my nodes left and right. I've got my Y variable A and B, so this is my class, and then I have my n's here to indicate how many fell into each group, as well as my proportions. I'm going to make a quick function that calculates that Gini index that we had learned about. So it's going to be P times 1 minus P. So let's make this a function of P so that I can just run this quickly. Okay, so the first thing I want to do is calculate my Gini index for this node. So you calculate a different Gini index for each node. And so my Gini index for the left node is just going to be Gini of this 0.4229. So the equation was you would sum up this P times 1 minus P for all of your K classes. In this case, we just have two classes, and so we can just do it the one time. And let's do our right Gini. I'm going to use this one as 0.6. So left Gini is 0.2449, right Gini is 0.24. And now, because I want a single summary for this split, I'm going to take a weighted average of these, and it's going to be weighted by the number of observations that are in each node. And so my first node has 7 observations in it, and my total sample size is 12. So I can do 7 out of 12 times left Gini plus, and then I'll take this, it's got 5 in the second and the right node, so 5 out of 12 times right Gini. So this is my Gini index 0.242 for splitting on X1. So the Gini for X1. Okay, now let's do that same exact thing, but let's do it for x2. So I'm just going to copy this code and bring it down here. I'm going to change these to x2 so we can see what that looks like. All right, so now we have slightly different numbers. So let's pull these down. So now my left Gini is going to be the Gini of this 0.833, so 0.833. My right Gini is going to be 1.67. That's this number right here. That's where I got that. And now, in this case, I've got, these are both equal, so they both are 6/12. Both of these groups ended up having the same number. This was, the left node had 5 plus 1, so 6, and the right node had 1 plus 5, so also 6. This is going to be Gini for x2. You can run that. So that ends up being 0.139. So my Gini for x2 is 0.139. My Gini for x1 is 0.242. So this one is going to be preferable. This 0.139 is going to be preferable. So I'm going to choose to split on x1. And so what that means is my tree is going to be, it's going to start with everybody in the top, and then my first split is going to be at x1, or x2 rather, since that's preferable. So I'm splitting here on x2 because this is the preferable Gini coefficient. So I'm going to split on x2. When x2 is equal to 1, I'm going to put people on the left. When x2 is equal to 2, or to 0 rather, I'm going to put people on the right. And what I expect from that is that on the left side, looking at this, it looks like I'm going to classify people into group A. On the right side, I'm going to classify people into group B. So let's check our work and see if this is what Tidy Models does. I'm going to make a model specification using the decision tree function. I'm going to set my mode equal to classification, tree depth equal to 2. My cost complexity I'm just going to have be 0. I'm going to set one more parameter that you don't really need to worry about, but I'm setting this min n because this is such a small sample size that it's actually not going to give us a tree because there are only 6 variables, and so it doesn't really know what to do with that. So I've got to set a minimum n here to let it know that it's okay for it to be so small. And then I'm going to set my engine to R part. What did I do here? Let's see, mode equals. Oh, I gotta run it from the top. There we go. And now I'm gonna fit my model. So I'll fit that model spec. Oops. Y equals x1 plus x2. Data equals data. Now let's do a quick plot to see how that looks. All right, it's as we expected. So it's taking the full data set, it's splitting when x2 equals 1, putting them on the right, it's classifying when x2 is 1 into group A, and it's classifying into group B when x equals 0. So there you have it. There's a little bit of more context for the Gini in case that's something you're interested in.